Bismillahirrahmanirrahim. Assalamu alaikum. So far we are done with the addition, subtraction and the multiplication, or you can say that the product of two functions. Next we're going to talk about the quotient of two functions, or you can say that the uh, division of one function with another. You divide one function, let's say f by g. What do we mean by this? So this means when you apply it on some x, this is a function f over g. So when you apply it on x, you can calculate it by f of x over g of x. So these two functions will be given to you. And don't forget that f of g and g of f over g and g over f are two different, functions. So they are not always equal. So this one and this one are not always equal. So whenever you will be asked to kind of find the quotient, you will be said that whether you have to divide f by g or g by f, because they have different answers. In the case of multiplication and addition, sum of two functions is same as f of g plus g of f is same, and fg and gf in the case of product is also same. But in the case of difference, I mean f minus g is not equal to g minus f, and similarly f over g is not same as g over f always. So you have to be careful, in that case. So let's without any delay, let's talk about the quotient of two functions. Consider you are given with one function f of x and the other function which is g of x. Suppose the domain of f is represented by dom f and the domain of g is represented by domain of g. That's just the notation. You can give it any name. I prefer to give this name. So this is a set, domain of f and domain of g. Next question is, so you can define their quotient f over g of x, which is equal to f of x over g of x. And you can also define g of f over f of g over f of x, which is g of x divided by f of x. Now the next question that comes to be answered is, what is going to be the domain of this function f over g? So the domain is going to be intersection, domain of f, intersection with domain of g. Further, you have to take the intersection, then you have to subtract those values of x where g of x is 0. So you have to first take the intersection, and then whatever the answer is, you have to exclude those values where this denominator is 0. Similarly, in this case, the domain of g over f is equal to the domain of g intersection with domain of f, and you have to take the intersection, and then you have to take the difference of those values where f of x is 0. So you have to do this additional things, first intersection and then exclude those values where denominator is vanishing. Further any delay, let's start with an example. I will take my function f of x, which is square root of x, and I will take another function g of x, which is square root of 4 minus x square. Now you can talk about what is going to be the domain of g. So domain of g is those numbers where 4 minus x square is greater than equal to 0, and once you solve this, you can just solve this and you can obtain this domain minus 2 to 2. So this is going to be the domain of this function g. All real numbers with minus 2 to 2. Minus 2 and 2 are also included. Next, what is going to be the domain of this? Domain of f it is, all positive real numbers. Non-negative real numbers, I must say, 0 is included. So if I was saying previously positive numbers, I'm sorry, 0 is included. So non-negative would be the better terminology. Now let me define f over g and then find the domain of f over g. So f over g of x is equal to f of x divided by g of x, and f of x is equal to square root of x, and g of x is 4 minus x square, which you can further simplify and write it this way: x over 4 minus x square. Maybe you can do that. Now the question is, what is going to be the domain of this f over g? So domain of f over g, first you need to take the intersection of these two sets. So domain of f over g is, first you take the intersection of domain of f and domain of g, and then we will subtract those values of x where denominator is 0. So first let's take the intersection of these two sets. So here we have this real line 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, so on. So the domain of f is the function which can be from 0 to plus infinity. This is 0 and you have to move to plus infinity, this. And then minus 2 to 2 is the domain of g. So this is the minus 2 and this is 2. So this is the domain of g here. Now you can take the intersection of these two. So intersection of these two is going to be the set which is from here to here, r 0 to 2. Is it going to be the domain? No, we have to subtract those values where denominator is 0. You can see that this denominator is 0 when x is plus 2 or minus 2. So this plus 2 is the value where denominator is 0. So you need to subtract this value. You need to remove this value from your domain. So the domain of your f over g at the end of the day, domain of f over g is going to be, intersection was this, but on 2 this denominator is 0, so it is going to be 0 to 2, but 2 is not included. I hope that makes sense. Similarly, if I was asked for the same question, what is going to be the g over f first and then find its domain, so it's going to be g of x over f of x. So g of x is obviously 4 minus x square over x square root. So this is going to be 4 minus x square over x. Now we can talk about its domain. So the domain of g over f is going to be equal to domain of f, g over f. So this is g over f. So this is going to be domain of g intersection with domain of f, and we will minus those values or subtract those values where denominator, in this case f of x, is 0. So now we have already seen that this intersection is 0 to 2, and we have to subtract those values where this f of x is 0 and f of x is 0 at 0. So this 0 will be removed from this set, so you will be left with 0 to 2. This is domain. So obviously you need to be careful that f of g, f over g is not equal to g over f always, and the domains also differ. That's it. Thank you.